Okay, welcome everyone. Marcus here. We're going to go through the Junior Maths Kangaroo 2024. All right, without further ado, let's jump in. So, question 1. My umbrella has the word kangaroo written on top, as shown on the diagram. Which of the following does not represent a view of my umbrella? So, my first thought with this question was kind of look, are all the letters in the right order? You spot that actually, with all of the 5 options, the letters are in the right order, but there's still one that you wouldn't see. And that's because one of the letters has been mirrored. Specifically, in this diagram, the letters are all facing one way, but the R is facing the opposite way. We notice that isn't happening on the original kangaroo umbrella. So the answer for this one is C, because the R has been mirrored, so it's not a view that you would see from the side. Look at question 2. Priya painted each of the 9 squares shown black, white, or grey. What is the smallest number of squares that she would need to repaint so that no 2 squares with a common side painted in the same colour? Now, because we're finding the least number of squares, we want to start with the smallest possibility. Here, the smallest possibility is 2. Can this be done just by painting 2 squares? So again, if we look over at the diagram, we need to think, okay, well, we need each square to be adjacent to ones of a different colour. So currently, these 2 are the same colour, these 3 are the same colour. So if we paint this one grey, that would solve some of the problems. And if we paint this one black, that would solve the other problem. And now, as far as I can tell, no squares with common sides are painted the same colour. So it is possible with 2, so that's why it's always worth starting with the smallest one. You may find it's possible with 3 as well. But by starting with the smallest possibility, you know that you found the answer there. Question 3. There are 12 ducks on Old McBride's farm. 3 ducks each lay 1 egg every day. 4 ducks each lay 1 egg every other day, and 5 ducks each lay 1 egg every 3 days. How many eggs do these 12 ducks lay in a period of 12 days? So the 3 ducks that lay 1 egg every day will lay 12 eggs. Or 36 eggs in total. The 4 ducks that each lay 1 egg every other day, well, over 12 days, they will each lay 6 eggs overall. Between them, they'll lay 24 eggs. And 5 ducks each lay 1 egg every 3 days. 12 divided by 3 is 4. So they will each lay 4 eggs, or 20 in total. We can add these values up to get the number of eggs 12 ducks. These 12 ducks lay in all 12 days, which is 80. Okay, which of these following fractions is closest to 2? So when you're comparing the size of fractions, it's useful to consider part size. So the size of the part is like the number of pieces that you cut a cake into, and that is the denominator of the fraction. So if we're splitting a cake into more parts, each part is going to be smaller. So if we look over here at E, that's going to have the smallest part size. So that's 1/10 away from 2. And all of the other ones are going to be more than 1/10 away from 2 because the part size is larger. 1/9 is larger than 1/10, so is 1/8, so is 1/7, so is 1/6. And you keep getting larger as you go towards the values on the left. So question 5, Sophie and Armin are playing a game. The winner of each game gets 3 points, the loser gets 1 point. Armin wins 6 games and Sophie has a total of 18 points. How many games do they play? The winner of each game gets 3 points and the loser gets 1 point. So if Armin wins 6 games, that means Sophie must have lost 6 games. And because Sophie gets 1 point for each game that she loses, that must have counted for 6 of her points. So she got 18 points. She lost 6 games, so that's 6 points. 12 points came from her winning games. So she must have won 2 games. Sorry. She must have won 4 games because each win is 3 points and she's got 12 points from winning. So in total, they must play 10 games because Armin wins 6 and Sophie wins 4. Okay, question 6. Molly and Holly each own a big dog. Molly's dog and Holly's dog weigh 80 kilograms in total. Molly's dog and a 20 kilo bag of food, dog food, weigh the same as Holly's dog. What is the weight in kilos of Holly's dog? This is a question that lends itself really nicely to using an equation. So we could call the weight of Molly's dog M and the weight of Holly's dog H. And we know that M add H is equal to 80. We also know that M plus 20 is equal to 50. Sorry, not equal to 50, is equal to the same weight as Holly's dog. So equal to H. So we're looking for the weight of Holly's dog. So you can think about how you want to combine these two equations together. We could start by writing the variables a slightly different way. So we could write minus M plus H equals 20, which is the same thing as saying Holly's dog minus Molly's dog is equal to the 20 kilogram bag of dog food. And then because we're working out the weight of Holly's dog, it makes sense to eliminate the weight of Molly's dog from these two equations. So we can do that by adding the two equations together. So M minus M is just 0. It gets eliminated. 2H is equal to 100. H is equal to 50. And that would, of course, make Molly's dog equal to 30 kilos. Still satisfies both equations. You do the kind of common sense check in your head. Okay, every plant in my mum's window box either has 2 leaves and 1 flower, or 5 leaves and no flowers. In total, the plants have 6 flowers and 32 leaves. How many plants are in my mum's window box? So in total, there are 6 flowers, and each flower corresponds to 2 leaves. So in total, 12 of the leaves correspond to those 6 flowers. So there's 20 leaves left over, and these correspond to plants with no flowers. So we know that if it's a plant with no flowers, then it'll correspond to having 5 leaves. Since there's 20 leaves, that's going to correspond to 4 plants with no flowers, plus the 6 plants with 1 flower. So in total, there's going to be 10 plants. Okay, looking at question 8. Alicia has 4 paper strips of the same length. She glues two of them together with a 10 centimeter overlap to make a strip 50 centimeters long. With the other two strips, she wants to make a strip 56 centimeters long. How long in centimeters should the overlap be? So we need to work out the length of each strip to start. Now we know the full length of one strip. Sorry, we don't know the full length of one strip. So we could just call that x. And this part of the strip is just going to be x minus 10, because we don't want to count that 10 centimeter part twice. We know that the whole length is 50, so 2x minus 10 is going to equal to 50 centimeters. I'm just going to write that here. I don't want my face to get in the way. Oops. So 2x equals 60 and x equals 30. Perfect. So each strip is 30 centimeters long. And now we want to reduce the overall length by 4 centimeters. So when we overlap the two strips, that middle section, you can think of it being subtracted away from one strip. So that one strip is still the same length, one has been reduced by the center part's overlap. So it's going to be B4. We want to reduce the overall length by 4 centimeters, but we just subtract that off one of the strips. And you think about the other strip kind of stays the same length as we've done in this example here. Okay. Next questions. So Elliot drew 6 squares, each with side length 1, to make the shape shown. What is the perimeter in centimeters of the shape? So, of course, you can just count up all the sides of length 1. The only tricky bit is working out these parts here. However, we know that the base is 3, and the 2 blocks above it is going to have a length of 2. So even though they kind of look like weird, like non-integer lengths, they're going to add up to 1, because the bottom, the base is going to be 3, the next row is going to be 2, so we're just going to be left with 1 there. And we can use the same logic for these 2 lengths as well. So if we just go around and count them up, we should get an answer of 12. Okay, question 10. Every day, Freya writes down the date in her diary and calculates the sum of the digits she writes. For example, on the 11th of June, she writes 11/06 and calculates 1 plus 1 plus 0 plus 6 equals 8. What is the largest daily sum she calculates over the course of a year? So, the first thought is just skip to the end of the year. Go for like 29th to 12th. 29th of December. You don't want to go past it. You want to go to the 30th or 31st, because then you start reducing the size of the digits. Even though the number gets bigger, the digits, the digit sum is smaller. Then that's also true comparing December to September. So September 09, the digit sum is 9. And for December, the digit sum is 1 plus 2, which is 3. So we're going to choose September over December, and also September over every other month. There's no month. The higher digit sum, then September. And then the number in September with the highest digit sum will be 29. Again, you want to have at least one of those digits being a 9, and then 2 is the highest tens digit that you can have, where the units digit can be a 9. It's going to be the 29th of the 9th, which has a digit sum of 20. Okay, on Abdication Street, there are 9 houses in a row. At least one person lives in each house. Any 2 neighbouring houses have at most 6 people living in them. What is the largest number of people that could be living on Abdication Street? Okay, so if you just took 3 people in each house, then we get 3 times 9, which is 27. However, because there's an odd number of houses, if you have 5 people in the first house and 5 people in the last house, you may be able to get more than the average just because it's weighted towards each end and because there's an odd number of houses in the row. So you can't have 6 people in the end house because then you'd have to have 0 people in the neighbouring house, and it says at least one person lives in each house. So we start with 5 at one end and 5 at the other end. It's going to go 5, 1. That forces the next house to be 5 because you want to make it as large as possible. 1, 5. Okay, so we get this pattern from the first house to the 9th house. We do the sum of that, we would get 25, 29. So 29, so it does actually beat the average if every house had 3. And there's not going to be a way to get more than that. The answer is D, 29. The rectangle PQRS is divided into 4 smaller congruent rectangles. The length of PQ is 1 centimeter. What is the length in centimeters of RQ? So given that PQ is 1 centimeter, that means because these rectangles are all congruent, the base of them is each going to be a half. And we can see RQ is just 2 bases plus one of the sides of the rectangle. So it's going to be 1 plus a half, which is of course 2. Diego notices that 20% of 30% of a number was 3 less than 30% of 40% of the same number. What was that number? So I generally encourage students to work in fractions rather than percentages. It's much easier. I also encourage it over decimals too, just because, doing the calculation, you may leave your answer in different forms, but doing the calculations, it's generally easiest in percentages because you can do things like cross cancel. So let's write this equation in fractions. So we have 1/5 of 3/10 of x I might use a different letter just because it looks like a times sign. 1/5 times 3/10 of n is 3 less than, so let's just add 3 here. So it's 3 less than, but we add 3 to make it equal to the other part. Then 3/10 times 2/5. So it's equal to 3/10 times 2/5 of the same number, which we've called n. So now it's just a process of simplifying and solving this equation. So once we've done that, we can start to simplify the fractions. So we can get 3/50n plus 3 is equal to 6/50n. So subtracting the 3 over 50n, we get 3 over 50n is equal to 3. So we multiply by 50, divide by 3, and n is equal to 50. Question 14. The area of a rectangle is 12 centimeters squared. The length of its sides, measured in centimeters, are integers. Which of the following could be the perimeter of the rectangle? Okay, so if we tried something like 3 and 4, that would make the area 12. But for rectangles, you can calculate the perimeter quickly by adding the two side lengths together and then multiplying by 2. So 3 and 4 is 7, times by 2 is 14. That's not an option. If we try 6 and 2, add them together is 8, times by 2 is 16. That's also not an option. So we have to try 12 and 1. Add them together is 13, times by 2 is 26. That is an option for the perimeter. So it's 26. Question 15. Mabel wants to color each of the 9 line segments shown in the diagram red, blue, or green. The sides of every triangle should be colored with 3 different colors. She already colored 3 of the segments as shown. What color can the line segment marked X be colored? So if we have a look at the diagram, we need to see, are there any line segments where we can tell the color for sure? Like, is there any ones that we can know for sure? Well, they all got to be different colors. So this one can't be red. Show you this one here can't be red because then it would be part of a red triangle. It also can't be blue, so then it would be part of a triangle which already has a blue line segment. So it's going to have to be green. So that means this one's going to have to be red. This one's going to have to be blue. Using similar logic to earlier, the one next to the blue, it can't be red, it can't be blue, so this one has to be green. So X has to be red. And because at each stage, we know it has to be the case, we know the answer is only red. Okay, a bag contains 3 green apples, 5 yellow apples, 7 green pears, and 2 yellow pears. George takes out pieces of fruit at random, 1 piece at a time. How many pieces of fruit must he take out to be certain he has at least 1 apple and 1 pear of the same color? So that's kind of like asking what's the most fruit that you can take out without getting 2 fruit the same. Well, he could take out 5 yellow apples and 7 green pears, and he won't have 1 apple and 1 pear of the same color. That's the most he could possibly do. We've chosen those 2 because there's the most of them. So he could take out 12 fruit without getting 1 apple and 1 pear of the same color. So he gets the 5 yellow apples and the 7 green pears. Now in the next piece, he has to take a yellow pear, which will go with the yellow apple, or he'll have to take a green apple, which will go with the green pears, as those are the only fruit that are left. So on the 13th fruit, he will be guaranteed to have at least a pair of fruit that are the same color. Okay. And question 17. In the sums shown, equal letters represent equal digits, and different letters represent different digits. What is the value of X plus Y plus Z? Okay, so we're adding 2 1-digit numbers to a 2-digit number to get a 3-digit number. So the 2-digit number is already going to have to be pretty big. And the 3-digit number is going to have to be pretty small. So we can probably, well, we know that it's not going to be 200 and something. Because if we add two-digit numbers together, we're not going to get over 200. And we're adding two 1-digit numbers to a 2-digit number, so there's no way that this is going to sum to a number over 200. The Z will have to be 1, because the hundredths digit has to be 1, and we know that all the digits are the same. So that's going to have to be 111. So again, if Y is 8, so we have 88, could potentially work. But if we add 9 at 9, which is 18, we're going to get 106, which actually doesn't get us to 111. So Y is going to have to be 9. It's going to have to be 99. And what do we have to add to 99 twice to get to 111? Well, that's 12. So X will be 6. And then 1 and 9 and 6 is 16. Awesome. Last page. Number 100 is multiplied by either 2 or 3. The result then has 1 or 2 added to it. Finally, the new result is divided by either 3 or 4. The final result is an integer. What is this integer? So we've got to check if more than one final answer is possible. So let's just follow the process as a tree. Let's multiply by 2 or 3. We then add 1 or 2 to the result. 201, 202, or 301, or 302. It's now divided by either 3 or 4. So if you remember your divisibility rules for 3, we know that it's divisible by 3 if the sum of the digits is a multiple of 3. So that works for 201. And we know that a number is divisible by 4 if the last 2 digits of the number are also divisible by 4. That doesn't work for any of them. So 1's not divisible by 4, 2 is not divisible by 4. So none of these numbers are going to be divisible by 4. And only 201 is divisible by 3. None of the other digit sums sum to a multiple of 3. So there's only going to be one possible solution, and that's going to be 201 divided by 3, which is 67. Question 19. In the 4-digit number PQRS, P, Q, R, and S are all non-zero and are in increasing order from left to right. What is the largest possible difference, QS minus PR, between the 2-digit numbers QS and PR? So to find the maximum difference, QS needs to be as big as possible and PR needs to be as small as possible. So if we could, we'd let Q be 9 and P be 1. However, we're told that PQRS are in increasing order. So that means R and S are going to have to be greater than Q. So the largest value for Q is 7, because that would make R 8 and S 9. So let's try that. Q7, R 8, S 9. P we want to be as small as possible, so we can let that be 1. Now, because R and S are both units digits, making Q be as big as possible is going to have much bigger influence on the overall difference between the two numbers than like trying to minimize R, the units digit of PR. So this will be the biggest difference. We make that subtraction and we get 61. Okay, notice 86 is actually the answer if you don't treat P, Q, R, and S as being in increasing order. You try and just do 98 minus 12. We know that we can't do that. So question 20. Harvey writes a number on each face of the cube. Then for each vertex, he adds the number on the three faces meet at that vertex. The totals he gets for vertices R, S, and T are 14, 16, 24 respectively. What totals does he get for vertex U? Now this is the question that I personally thought was most interesting on the whole kangaroo. Really liked this one because I hadn't seen something quite like it before. So let's label R, S, and T with those numbers. So, and we're looking for U. Now, what you might notice is that T and R are opposites, and S and U are opposites. So the three faces that add up to T added to the three faces that are summed to R will actually be the six faces of the cube. So by adding T and R together, you can get a total sum for all of the faces on the cube, which is going to be 38. Now, because S and U are opposites, to get the three faces by U, we can subtract the three faces by S. We do 38 minus 16. And because we're left with just those three faces, which are next to the vertex U, that will leave us with 22. 38 minus 16 is 22. Very clever question, that one. I like that a lot. And this wasn't the original way I did it. I didn't actually spot this until I'd actually approached this question in a slightly different way. Question 21. A train has 12 carriages. Each carriage has the same number of compartments. Ileana is travelling in the 7th carriage and in the 50th compartment from the front. How many compartments are there in each carriage? So yeah, first read of this question, it almost doesn't feel like you have enough information to solve it. But let's have a think about this logically. She's in the 7th carriage. And let's say that there are X compartments in each carriage. So there's 6 X compartments in all the carriages in front of her. Plus the number of compartments in front of her in her own carriage. And that's the total of that is equal to 50. So when we think of what possible values X could be, well, if there's 7 compartments in each carriage, then there'd be 42 compartments in the 6 carriages in front of her. But then she'd be in the 8th carriage she'd be in the 8th compartment in the 7th carriage. But we just said that there are 7 compartments in each carriage, so that wouldn't make sense. So if X is 8, there's 8 compartments in each carriage, then there'd be 48 compartments in the 6 carriages in front of her, and then there'd be 2 compartments in front of her in her own carriage. And of course, that would make sense. 8 would make sense. If there's 9, that wouldn't make sense because 6 times 9, 54. That would mean that there's 54 compartments in front of her in the first 6 carriages. So that's more than 50. That wouldn't make sense. So we've shown that it can't be 7, it can't be 9, it can only be 8. Okay, question 22. In how many different ways can 3 kangaroos be placed in 3 different cells of the grid shown so that no 2 adjacent cells both contain kangaroos? So I think the best approach for this question is just counting them up. To start with one arrangement, let's just call them here, here, and here. That's one option, and then we can just move that each option one by one. So that'd be the second option, the third option, fourth option, the fifth option, the sixth option. Sorry, this is probably getting really boring. And then once you've done that, you're going to have to move the first one, number 7, number 8, where was I? Number 9, and number 10. And there's no more that we can do. So the answer here will be 10. Okay, Joe, Flo, and Mo divided up a sum of money. Joe took £10 plus a quarter of what was left. Next, Flo took £40 plus a quarter of what was left. Finally, Mo took what was then left. Joe and Flo took the same amount of money. How much did Mo take? So again, its best approach is probably just going to be to try and form an equation. We're told that Joe and Flo take the same amount of money, so that's how we're going to equate two things. So if the amount of money is M, Joe took 10 plus a quarter. So Joe's amount of money is 10 plus a quarter of the total amount of money minus 10. That is Joe's amount of money. So now the total amount of money left is M minus this, minus the amount that Joe took. And then Joe took £40 plus a quarter of the amount of money left, which is now, and I'm going to need a little bit more space to write this. M minus Joe's amount, and it's also minus 40 for the amount that Flo just took. So M minus 10 minus a quarter, M minus 10 minus 40. That should tell us the amount of money that was left after Flo had taken her £40. Okay, this is pretty ugly, so we're going to start trying to tidy this up. So rather than multiplying by a quarter, it's going to make more sense to multiply by 4, both sides by 4. We'll do that after we subtract 10 from both sides. So we get 30 times everything by 4, and then we get M minus 10 is equal to 120 plus M minus 10 minus a quarter, brackets M minus 10 minus 40. Okay, let's collect up all those terms. So add 10 to get, so those two will just cancel. So 120 minus 40 is 80. And those M's will just cancel as well. So we end up getting a quarter M minus 10 is equal to 80. Times both those by 4 to get 320 and add 10 The original amount of money was 330. So if the original amount of money was 330, we can sub that back in here to work out the amount that Flo and Joe took. So 330 minus 10, 320, times by a quarter is 80. So that, when M is 330, overall, that's going to equal 90. So each of them took 90, 330 minus 180 is equal to 150. And that must be what remained for Mo. Okay, question 24. I'm just going to get rid of some of this working just so I've got space to write some working for question 24. So 4 points lie on a straight line. The distances between the points are increasing order 2, 3, k, 11, 12, 14. What is the value of k? So imagine this line. The distance between points that are furthest away is 14. We've got these two other points on the line somewhere along the line. This next value is 12. So let's let that length be 12. The next smallest value is 11. So that's going to have to be close to the point on the left, because if it's close to the point on the right, then it's going to be a shorter distance, basically, than 11. That means this length is going to have to be 11. Now, if we look at the smaller lengths, that means this length is going to have to be 2. This length is going to have to be 3, because we've got the 2 here and the 3 here. So the only length that we don't know is the one between these two middle points, which now, using all the lengths we have, is going to be 14 minus 3 minus 2, which is going to be 9. And final question, 25. Hayden used small cubes of side 1 to build a large cube with side 4. Then he painted 3 of the faces of his large cube red and the other 3 faces blue. When he finished, there was no small cube that had 3 faces painted red. How many small cubes had both red and blue faces? So given that there was no cube with 3 faces painted red, then this kind of tells us how the faces were painted. So if we just draw a little cube, oops, but not behind me. Apologies for the most rough sketch of a cube you've probably ever seen. So we can't have these 3 sides being red, because then we'd have like this corner painted with 3 faces red. So that means the base, or this side, would have to be red, and we're kind of going to get a strip of red and a strip of blue. And then if we think about how many edges there are that border a red face and a blue face, so if we say the base is red, then there's going to be just a different color. This one, this one, this one, this one, this one, and this one that we can't see, and this one that we can't see. So there's going to be 8 edges in total that border both a red face and a blue face. Now, we don't want to double count any of the edges because some of these are corner pieces and they will be on 2 edges. So rather than counting it as 4 blue squares on each edge, 4 blue and red faced cubes on each edge, we could count it as 3, where one of the corner pieces then counts towards the next edge. So we could go 1, 2, 3, and then this one counts here. 1, 2, 3. Again, this is a terrible, terrible diagram, but hopefully you're starting to get the idea. And then once, it's just a slightly faster way of counting them. You could just count them all one by one, and that would also be fine. To summarize, we can just do 3 times 8 here to calculate for the 8 edges the total number of cubes. So the final answer will be 24. Okay. I hope that's helpful to you. I hope you've enjoyed going through all of these Junior Kangaroo questions. And if you have any questions, if I didn't explain anything well enough, just drop me a comment drop me a comment below, and I'll be happy to get back to you and hopefully clarify anything that you'd like me to. So speak to you soon. Goodbye for now.